Hello, welcome. We are now in Chapter 4, dealing with uh, water. That's right in front of me. All right, here are the learning outcomes for this chapter. And water. Water is a really unique substance. It's relatively high density for a liquid, and when it freezes, expands. There's the most common form of ice, at least. There's other forms of ice that can sink in water, in liquid water, but the most common form floats in water, which is pretty strange. It's a really good solvent. So it's great at transporting nutrients in things like our bodies and in the biosphere and the hydrosphere, but it also is great at transporting poisons and toxins as well. Water is amphoteric, meaning it can act as an acid or a base. So there are other things that are amphoteric, but water being amphoteric is interesting. It has a pretty high heat of vaporization, so this is when it takes a lot of energy to vaporize a little bit of liquid. Also, when water condenses, it releases a bunch of heat as well. So this corresponds to lots of weather events. So when storms have lots of power, it is from this, the amount of heat there. It has a relatively high specific heat. So to give you an idea, so the specific heat meaning like you have to, what it means to how much energy it takes to raise a certain amount of temperature. So metals, for instance, have a very low specific heat. So right, so if you go out and you have a hot piece of metal, right? So let's say I stick a spoon in boiling water, and then I take the spoon out of the boiling water, then I put it on my arm, and that's a lot of heat. I mean, the spoon's at 100 degrees Celsius, but it's probably not. It's gonna hurt, but it's probably not gonna burn me if I put a metal spoon on my skin because there's not a whole lot of heat transfer. Then again, if I put boiling water and I pour boiling water on my skin, that the temperature the water is gonna release a lot of heat, and the temperature is not gonna go down by that much. It'll continue to release heat, and then it can cause some damage there. So relatively high specific heat. And so about 75% of the Earth's surface is covered in water. So most of this is seawater, and we have about 2% of it frozen in the ice caps. So water in nature, and of this fresh water, most of it is in the ice caps. Then we have groundwater, surface water. We have, you see here, we have very little in lakes and rivers. Uh, but if you watch where cities grow up, they tend to appear along rivers, and some of them are coastal as well. And well, there's a lot of coastal cities, but coastal also along rivers. I mean, so London is on the River Thames. The France is on the Seine. I used to live in Budapest. It's on the Danube, and I grew up in Cincinnati. That's on the Ohio River. So rivers are in around a lot of cities. Okay, water cycle. Here's the water cycle. You have the sun. I can just imagine a happy sun here. I remember one time I had a student. I drew a sun one time, and he or she drew some sunglasses on the sun. I always think about that. But so the sun. Imagine some sunglasses on the sun. The heat from the sun goes typically over the ocean, or well, I mean, it goes over the entire Earth. But then the water evaporates from the ocean, and then it causes then there's condensation and precipitation. Gets locked up in snow, and then the water runs off in lakes and rivers and absorbs in the groundwater, and eventually flows back into the ocean. So that's the water cycle. There are some natural contaminants in the water. We have gases of I don't know if you want to call it a contaminant, but oxygen is important in the water. You could argue that's a contaminant. Dissolved minerals. So this is what causes hard water. So there's pretty hard water in Hawaii because we get our water typically from the groundwater. Organic matter, so bacteria and various other pollutants. So here are some substances that are found in water. Carbon dioxide, there's quite a bit of that, and various gases from the atmosphere, and just the various minerals and ions there. And let's talk about disease, waterborne disease. So 30 million people in the United States are threatened by bacterial contamination. And that's quite a bit. That's about 10% of our population. and estimated that 80% of the illnesses is caused by water contamination. So that's very dangerous. That's a lot. I mean, 80% of illness. That's obviously a very large fraction. And how do you get around that? Well, sterilizing, having access to clean water, of course, will greatly decrease waterborne disease. Acid rain, we talked about this in previous chapters as well, has to do from sulfur oxides and nitrogen oxides, SOx and NOx, causing acid rain. And also sewage, the increasing biological oxygen demand. It's not necessarily sewage. Well, I guess I'm thinking of sewage. It's there's chemicals, certain chemicals that when I think of sewage, I think about human waste. It's much of it is from personal care products. So things like certain soaps can increase the biological oxygen demand. So hydrocarbons, because bacteria eat those and then consumes oxygen. And also can lead to eutrophication of a lake. The next slide is on eutrophication. And the matter can go aerobic or anaerobic decay. Aerobic means with oxygen, anaerobic means without. So here's an example of eutrophication. It's a natural process, but eutrophication is the addition of nutrients. And those can cause algal blooms, which can then choke out the rest of the waterways. And there are some natural eutrophication, and so around Alaska, with a change of season, so algae more or less grows until it is limited by a nutrient. And around Alaska, the nutrient that's limited by is sulfur. And the ocean is relatively shallow there. With a change of seasons, sulfur comes up from the bottom of the ocean, and then causes huge algal blooms. Then krill eat the algae, and bait fish eat the krill, and so on. And we have the whale migrations. The humpback whales go up and they gorge themselves on krill and bait fish that have grown from this eutrophication, this natural eutrophication, and then they come back down to Hawaii to mate and give birth to their young down here in the islands. So, eutrophication can cause, for anthropogenic, so human caused, can cause significant damage to waterways from this. So, what do we use water for? This is about how much water is required. So to make certain things. So water required for various things. And you can see many of our products require quite a bit of water to produce. And the water required. So if you look at this chart, you have industrial products or water required, and the B says per metric ton of product, and this includes, so this irrigation water, rainwater consumed directly and used in processing. So this is all the water that you need to make these various things. Okay, and what do we use water for in the United States? To cool electrical power plants, so that causes thermal pollution. Irrigation for our crops, public water supplies, that's for our drinking and using the toilets and showers and that kind of thing. Industrial use and miscellaneous kind of stuff. Miscellaneous includes mining, livestock, aquaculture, various uses. So, and about 1/2 of the U.S. population gets its water from groundwater use. I get my water from groundwater use in Wailuku. That's where we get our water sources, groundwater. So many of these places are contaminated, and it's very difficult to clean up contaminated groundwater. How do you contaminate it? Nitrates is one way. So nitrate ions can cause various conditions like blue baby syndrome. Also, volatile organic compounds can contaminate groundwater. This is things like just dumping oil into waterways or into the ground. So this is one way to damage the groundwater. And also, we have lots and lots of public water systems, and we use quite a bit of this. And our use exceeds, we're pretty water fat here, and we use a lot of water in the United States for this. And we passed the Safe Drinking Act in 1974. The Environmental Protection Agency monitors this for human health hazards. Uh, if you compare the United States to the rest of the world, the United States has very strict air quality controls, but we have relatively lax water controls. Europe has extremely strict water controls, but they don't have as many air controls. So, and the developing world has neither really. They don't have as many strict laws. So you will have cleaner air here in the States, but dirtier water, and you'll have dirtier air in the European nations and cleaner water, generally speaking, I guess. Okay, so here is what the EPA has set for the standards for various waters, for the water. Okay, and this is continued. And some of the terms, so parts per million. So percent is parts per 100, and parts per million is per parts per, like, 1 part per million, and parts per billion is one part something per billion of everything else. So this is for very small amounts for parts per billion to track things. So and most urban areas, we have water treated in a water treatment facility before it goes to homes for consumption. So we certainly have this in Hawaii, which is nice. Well, some areas just have water collection. Um, it depends. You can have many homes have in the mainland just have well water. So how do you do this? Well, we uh, first thing we do is we add lime and alum to it, and this forms what's called a supplicant, and that means that stuff floats on the surface. So it coagulates and it forms a supplicant. So a precipitate floats to the bottom, a supplicant goes to the top, and it forms a supplicate, and then we gather the stuff off the top. And then typically we use chlorine or ozone to treat to get rid of the bacteria. So this it's very often used. Chlorine is the most oftenly used. Ultraviolet light can also be used. Various places use ultraviolet light. Maui uses chlorine. Oahu sometimes doesn't use chlorine. Depends on the bacteria level. They test their bacteria level before they distribute the water in Oahu. They just chlorinate the water in Maui. Okay, so here is a water treatment plant. Water intake, and you have the alum, and then you have the water go through a sand filtration. Sand filtration, this is an old technology. It's the ancient Egyptians are the first ones to do this, and the idea here is there's actually bacteria in the sand filter that eat any impurities. Typically, you have anthracite coal in this as well. And the anthracite, the coal makes a sand filter last a long time. And you can clean the sand filter by reversing the flow of the water. When you reverse the flow of the water, you get rid of all the gunk out of it. And so you can do that a few times before you have to replace everything in the sand filter. So then the air is aerated, and then chlorine is added to kill any bacteria, and then it goes to then it's passed on to the rest of the city. So ultraviolet light, oh yeah, ultraviolet light can also do this. And one thing though that I mean, chlorine and ozone, especially chlorine, has a residual protection. The UV light just on the spot sterilizes it, and then if you in the right circumstances, it can be contaminated again. So fluorides in Hawaii, we do not add fluoride to our water. We also have a pretty high incidence of cavities, but this has been done to prevent tooth decay. And they found out it was a city in Colorado. There was a town that had very few cavities but had stained teeth, and a dentist was very curious about this. Found out it was from the fluoride caused it. And how does fluoride work? It replaces hydroxide in the hydroxyapatite. That's the mineral that's on teeth, and this makes the enamel harder and less soluble. Fluoride also is toxic to bacteria, so it does lots of things. So your mouth, though, in your saliva, you can remineralize your teeth that way. So you can grow new tooth enamel using the saliva. And when you have plaque on your teeth, the plaque is just it's the food and the various sugars left over from food, and then bacteria can grow on that. So that kind of food and bacteria, if that becomes mineralized by your saliva, that's also known as tartar. So tartar is tooth enamel that's grown over uh, plaque, and that's also the dentist can scrape it off with the tools. Okay, so fluoride usually use add these chemicals here to it, and it's produced a decrease in dental cavities. So we need uh, well, since we don't have this in Hawaii, it's important that you should brush your teeth twice a day using a fluoride toothpaste. So, especially if your diet is high in sugar. So, and also before we return water to the environment, it should be treated. So, there's various levels of processing: primary, secondary, and tertiary. So primary treatment is just to remove the solids. So primary treatment, remove the solids, and then the secondary treatment involves, well, if you're going to have just primary, chlorine is not necessarily used in the uh, in the primary. Primary is just to remove the solids. Secondary treatment uses bacteria and activated sludge. So activated sludge, it's bacteria that consumes the waste product, and it can be it's aerated to give it oxygen, and then the sludge is recycled, collected and recycled and used again, and then is typically then sterilized after that. The tertiary treatment, not always used, but tertiary treatment can use charcoal filtration or reverse osmosis or various filtration to further clean the water. Tertiary treatment is typically not used in the United States. Various places, Kihei and Maui uses tertiary treatment because then they take the water from the wastewater treatment plant and use it to irrigate the golf course, for instance. So, okay, so alternative treatment systems. So sludge, we can take the sludge and use it as fertilizer. This is used in many areas of the United States. You can use settling in ponds and then let the effluent go into marshes, and also using compost waste toilets that do not require additional energy or water. So with this, though, water is very important, and water is an increasingly uh, diminishing resource, and um, it is predicted that water resources are going to be a source of major international conflicts in the future. So, and this is very important. Water is very, and I mean, I know that it's hard to say that this is let's say important. Many things I talk about in this course are important, but this is something that is knocking on our door soon. That our water resources are diminishing, and we've also damaged some of our water resources. So I will end this slide here, or this here, and I will see you next time.